Gold is formed deep within the Earth's crust over billions of years. It originates through various geological processes. Gold exists in trace amounts within rocks. It is also found in ore deposits. These deposits are the primary source for gold extraction. Geologists employ advanced technologies to pinpoint gold-containing ore deposits. These technologies enable geologists to see beneath the Earth's surface. The ability to see underground helps identify potential mining locations. Advanced tools enhance the accuracy of ore deposit detection. This leads to more efficient and targeted mining operations. Ultimately, these technologies optimize resource extraction. Open-pit mining extracts gold spread near the surface. Large excavators remove tons of rock. This process exposes the gold-bearing ore. Trucks transport the ore for processing. Open-pit mines are characterized by their immense scale and scope. These operations involve extracting large volumes of earth. This extraction process dramatically alters the natural landscape. The alteration is due to the sheer size and depth of the excavation. Underground mining is essential for extracting gold veins located deep beneath the surface. This method allows access to gold deposits that are otherwise unreachable. Miners use elevators to descend into the network of tunnels. These tunnels provide access to the gold veins for extraction. Underground gold mining involves extracting gold ore from within the earth. Miners use blasting or drilling to break the rock containing the gold ore. This process often occurs within narrow tunnels deep underground. Careful extraction is required to maintain safety and efficiency. Mined rock is transported from the extraction site to crushing facilities. These facilities are equipped with powerful machinery for ore processing. Giant crushers are used to break down the large rocks into smaller pieces. Grinding mills further refine the crushed material into a finer consistency. This process prepares the ore for subsequent stages of mineral extraction. The crushing process is essential for efficient mineral recovery. The crushing process reduces large rocks into smaller fragments. The grinding process further refines these fragments into a fine powder. This fine powder resembles a sandy texture. The primary goal is to increase the ore's surface area. Increased surface area enhances the efficiency of subsequent processes. This is achieved through mechanical reduction of particle size. Gold powder is mixed with water to form a slurry. The slurry is then processed using froth flotation. This method separates valuable minerals from waste. Froth flotation relies on differences in surface properties. Air bubbles are introduced into the slurry. Gold particles attach to bubbles and float to the surface. Froth flotation is a method used to separate valuable minerals from ore. The process involves creating a slurry by mixing finely ground ore with water. Air is then blown through the slurry within a flotation tank. Special chemicals are added to selectively bind to the desired mineral particles. These chemicals cause the mineral particles, such as gold, to attach to the air bubbles. The mineral-laden bubbles rise to the surface, forming a froth layer that is then collected. Froth flotation is a process used to separate valuable minerals from ore. In this process, air is bubbled through a slurry of ground ore and reagents. The reagents make the gold particles hydrophobic. These hydrophobic gold particles attach to the air bubbles. The gold-laden bubbles rise to the surface, forming a froth. The froth is skimmed off, concentrating the gold for further processing. Cyanide leaching is employed to extract gold from low-grade ore. The process involves using a dilute cyanide solution. This solution helps dissolve and separate the gold particles. The gold is then recovered from the cyanide solution. Cyanide leaching is a chemical process used to extract gold from ore. A cyanide solution is applied to the ore. The cyanide chemically bonds with the gold particles. This process effectively separates the gold from the rock. Collected gold often contains impurities that must be removed. The impure gold is placed into a high-temperature furnace. The furnace heats the gold to its melting point. Melting allows impurities to separate from the gold. These separated impurities can then be removed. This process refines the gold to a higher purity level. Electrochemical refining is employed to purify gold to a high degree. The process involves using molten gold as the electrolyte. An electric current is passed through the molten gold solution. This causes gold ions to migrate and deposit on the cathode. Impurities are left behind in the electrolyte solution. The result is gold, with a purity level of 99.99%. The refining process culminates in the production of a gold bar. This bar is characterized by its high purity. The gold bar possesses a gleaming appearance. The refining process removes impurities. The gold bar is ready for various applications. The gold bar is a valuable resource. Pure gold is inherently too soft for use in jewelry making. To enhance its durability, gold is alloyed with other metals. Alloying involves mixing gold with metals like silver or copper. This process increases the hardness and strength of the gold. Different metal combinations result in varying colors of gold alloys. These alloys are essential for creating durable and aesthetically diverse jewelry. Carat values indicate the proportion of pure gold in a gold alloy. Higher carat values mean a greater percentage of pure gold. 24K gold is pure gold, while lower carats contain other metals. The carat value affects the color of the gold. Higher carats are more vibrant. Durability is also affected. Lower carats are generally more durable. The choice of carat depends on desired color, purity, and durability. Alloying gold involves mixing it with other metals to alter its properties. The type of metal used in the alloy significantly affects the final color. White gold is created by alloying gold with metals like palladium or silver. These metals lighten the gold, resulting in its characteristic white hue. Rose gold, on the other hand, is produced by alloying gold with copper. The addition of copper gives the gold a reddish or pinkish appearance. The jewelry casting process begins with a wax model. This wax model accurately represents the final jewelry piece. The wax model is then used to create a mold. This mold will be the vessel for the molten metal. The casting process transforms the wax model into a metal jewelry item. The jewelry casting process involves pouring molten metal into a mold. This mold is created by first using wax to form a model of the desired jewelry piece. The wax model is then melted away, leaving an empty space within the mold. Molten gold alloy is poured into this cavity, filling the void left by the wax. After the molten gold cools, the mold is carefully broken. Breaking the mold reveals the newly cast gold piece. The gold piece is now in its desired, albeit raw, form. Further processing is required to refine the piece. This includes cleaning, polishing, and detailing. Jewelry can be handcrafted by skilled artisans. The process involves meticulous sawing of the metal. Soldering is used to join different parts together. Artisans carefully shape the gold into desired forms. Traditional tools are employed throughout the handcrafting process. The initial step involves filing the gold piece to refine its shape. Filing removes imperfections and prepares the surface for polishing. Polishing is then performed to create a smooth, reflective surface. This process enhances the gold's aesthetic appeal, resulting in a sparkling finish. Precious stones are often selected for their quality and beauty. These stones are then carefully set into gold jewelry pieces. The setting process requires precision to ensure secure placement. After setting, each piece undergoes a final quality check. This inspection ensures the jewelry meets high standards. The finished jewelry is placed in a velvet box, ready for sale.